그 LG에는 여러 가지 종류가 있는데 요즘은 그냥 LG를 그 옛날에는 겉으로만 판단했잖아요. 나이로만. 아, 너무 비싸. 요즘은 LG를 여러 가지로 나눈다.
그렇지.
장기마다.
혈액, 장기,
열 가지로 넘게 있다. 여기까지.
그러니까 그 동안에는 우리가 지금 그 노화에 대한 정의가 없더라고요. 그 노화가 뭔가 정의가 없다는 거예요. 누가 실질적으로 논문도 없더라고요. 그런데 지금 그거를 한 10가지 정도로 노화를 척도를 할 수 있는 과학적 이유를 한다고 얘기를 했고.
예, 근데 아직
Yeah, so basically, what he does is he's able to just look at the very routine, easy, complete blood counts and metabolic profile. What he can do is he can look at the numbers and give you an estimate for the different age. Like what's the heart age, maybe biological age is 50, but the heart is only 30 years, right? And based on the ASTLT, they can give you the age of the liver and so on and so forth. So it's very simple, and it has this one particular algorithm has been validated from external. The algorithm was trained at male using American data, has been validated by 2 or 3 data set from outside. So basically, it's been confirmed it's the right algorithm and it's pretty happy. The other day I was talking with your family and we were talking, since you have patients who have been taking the supplement for 4 years already, right? Since all the South Korean citizens, they have the annual checkup, right? You should have information already, right? So the CDC said 4 years before taking the supplements and 4 years right now after taking the supplements. You can basically compare those particular population who has been taking medication versus the population who has not been taking medication. So you can do a population, not necessarily called cohort comparison, and say, okay, does the taking the nitric oxide metabolite actually slow the aging process, or even reverse the aging process?
그러니까 이제 그 동료가 있는데 남자 동료가 있는데 그분이 하는 게 이제 그런 신체 나이를 측정하는 거예요. 혈액이든 아니면 간이든 그렇게 해서 측정을 하는데 이게 데이터가 쌓이다 보니까 하나의 알고리즘을 지금 하나 만들게 된 거예요. 네, 그래서 이 알고리즘으로 먹기 전, 먹은 후 이렇게 해가지고 어느 정도 뭐 실제로 이 사람의 생물학적 나이는 50인데 뭐 여기 장기에 나이는 몇 살이다라고 이렇게 말을 해줄 수 있는 알고리즘을 만들었고 그 알고리즘이 3자 파티 뭐 두 기관에서 검증도 받아서 꽤 정확하다라는 건 지금 어쨌든 그런 정도까지 나와 있는 상태예요. 그래가지고 예를 들어서 지금 한국에서 1년마다 건강 검진을 하기 때문에 이런 데이터가 모두 다 나와 있지 않아요.
나와 있어.
그래서 에노를 먹기 전 사람들과 그리고 먹은 후의 사람들의 그런 데이터가 있기 때문에 여기 알고리즘을 두면 그런 결과들이 싹 다 나올 수 있다라는.
Can I ask you a question? How do you look at confounders and confounding data, different drugs, and the diversity of patients that you're getting in that?
Yeah, that's very
Because that's the biggest problem that we have when we're looking at clinical data. Right? So even the smallest of the, if forget about the RCTs, smallest of the open label trials that you do, or if you take patient data from, let's say, all of us or UK Biobank, the biggest problem is the ICD-10 codes are very subjective. Every patient, every doctor weighs it in a very different way. It's extremely difficult to look at that. Second is the lack of confounding data when the data is coming from various different types of sources becomes extremely difficult. What exactly is a medication that any particular person is taking? How good are they while taking that medication? Is it that it's only on the paper but they're not taking it as compared? These are real problems that you get, especially when you're looking at metadata. So we have done all of us data analysis for like thousands of patients. The biggest problem that you get is patient reported outcomes are horrible. And then the second biggest problem is ICD-10 codes are very subjective. Now this is when you're looking at data that has been gathered in traditional clinics. And traditional as in the mainstream clinics. When you talk about taking data from traditional clinics, traditional medicine clinics, you don't have ICD-10 codes at all. That becomes the biggest challenge. So how are you going to look at that?
Yeah, that's very, very good question. Unfortunately, I think some of the comments you made are absolutely valid, right? You know, especially for the medication compliance, right? Even in the, this is a, you know, again, it depends on the population, right? So I'm not sure about the, like, you know, there's a study actually compare different hospitals, different, how to say, like social economic status, right? They do play a major role in the
Yeah.
compliance rate, right? So the good thing about Mayo Clinic is, you know, most of our patients actually are privately insured and they are pretty highly in the economic status. So for us, I don't think we have the paper published. We have some data showing actually that the compliance rate is super high compared to,
Yeah.
you know, if you look at patients who are in the community or city hospitals. Yeah, ICD-9, ICD-10 code, you are absolutely right. They are notoriously, you know, bad.
I mean, like
documenting.
gastroparesis, functional dyspepsia, IBS,
Yes.
bloating. Impossible to put them into ICD-10 codes, right?
Absolutely. Absolutely. So, you know, for that particular purpose, actually, sometimes, you know, after we retrieve the data, we do validation. So we retrieve about 5% of the case. We go and validate, make sure they are relatively accurate. So we always check the accuracy, like is 86% or is 90% or, you know, is below a certain percent. So we always do that part. I'm not sure. Maybe you guys did the same.
No,
thing?
so thanks. The thing that I was trying to convey is that it works very well when you have very controlled populations, right? It's to give you an analogy, it's like the Apple versus Windows ecosystem. In Apple, the hardware is made by Apple, the software is made by Apple, everything is tested on Apple. When you have Windows or Android, you have diversity. And when that diversity of data collection comes in, most of these AI models fall apart.
Yes, that's super important. That's why, you know, most of the AI algorithms actually they work well in one medical system and they fail in another system because the way how you capture the data, how to document it can be super different. Yeah, so that, you know, that bring the harmonization of the data into the question, right? How do you harmonize data? How do you make the data actually more uniform between different medical systems? Yeah, I think there's definitely a challenge if you were going to have the data gathered and validated in the States and then bring to the South Korea to have them validated here. So I think there's definitely a challenge there.
So the closest actually anybody came was in the UC system. Atul Bhutte, when he was alive, he made a thing where every single data point that comes into the UC system, you go to any University of California, smallest of smallest clinic, big hospitals, all that data is gathered, and CMP, CBP data and everything, right? So that allowed them to do some amount of predictability, but their predictability was like 46%. Even within the UC system, because the ICD-10 codes and patient compliance was just all over the place.
I think that I think clinically, when you see the data and trying to analyze in different systems, you might end up with some different results. Especially in aging, because of the lack of standard, we don't know the indication. What's the biomarkers, and especially the people organs. There's a lot of things we need to kind of standardized, and then
But
then
there's
they
one-
work together. I think the different system using the different tools and people, and then you might end up like different.
So that's why I published this paper with a bunch of aging scientists. And I think it was published in PNAS. I can't remember where. It was a white paper. Can we agree on certain minimum things?
Yeah.
What is aging? We cannot agree even on that, right? So that's the consensus at which the community has right now, and that's why it's extremely important to actually have validated biomarkers. That's what I keep harping about, is that unless you have clear biomarkers, and they may be anything. They may be blood-based biomarkers. They may be lipidomics. They may be epigenetics. It can be anything. Unless you have a clear biomarker that says this is before, this is after, and this is the significant difference that you're having, and this is associated then with physiological data, then that becomes acceptable. Without having a biomarker, classic case like IBS, for example, right? I'm just saying this because we all understand IBS to some large extent. Many of these diseases go up and down in days. There are days when a patient is better, days when a patient is worse, and it goes back up again. The biggest problem that we don't have good drugs for IBS is because the placebo acts in 40-50% of patients and drugs work in 60% of patients. The difference between them is so small that it is not significant. Why? Because it depends upon where exactly in the curve you are. If the placebo itself is going to be given at the time when the patient is lowest, the only natural trajectory of the disease is that the patient is going to become better. And that's where your final endpoint is. Quite a lot of these diseases of aging are asynchronity diseases.
Yes, that's why they have totally different organ aging, right? So
교수님,
one organ age faster
나도
than
얘기 좀
other.
해. 내가 어쨌든 호스트니까 나도 얘기 한번 해보겠다.
So do people use NAD as a part of the aging biomarker? Of
That's
course,
a big.
blood.
That's one of the biggest pushes that the NIH is having right
Yeah,
now. Is how do you define biomarkers of aging? So there are different companies that are in the game as well. Everybody wants to remain young. Nobody wants to die. Okay, and the people who are actually funding this are people like Jeff Bezos, Vladimir Putin, and all these guys.
And the C.
I'm not going to say more names because everybody wants to live longer. So then, how do you define whether you're going to live longer? Now, they don't want to find out till the day that they're going to die, so they want to have biomarkers by which they can say, "I'm becoming better." So people are trying to do biomarkers based on epigenetics. Dr. Rowe understands epigenetics very well, and where is Benjamin? Now he understands epigenetics. So people are trying to do epigenetics, but then what they find with epigenetics is if they use epigenetics as a molecular clock, then it's not exactly it's defining your age. It's defining whether things are changing or things are not changing. Still not a very good indicator for longevity. Then people are defining biomarkers as is your lipid profile better? Is your blood profile better? Oh, that's great.
What is this?